I have few tasks for you guys. As in when you answer that, we'll get introduced to the idea of integration. So the very first task is to add the following numbers. So can you do that? Okay, along with that, can you add this as well? Okay, let me answer this. So this is nothing but 23 being added 10 times. So I can do this, right? So this is basically nothing but your multiplication. So underlying principle over here is, from now onwards, I'm going to call it as UP is multiplication. Now over here, this set of numbers I will represent in a different manner. Oh, my bad. So this is your set of numbers. Can you see that? So this is 5, this is 8, this is 11, this is 14, this is 17, so on and so forth. So 10 such numbers are there. So if you observe carefully, what is the general funda over here? What can I tell you about the graph? What's happening over here? The height is fixed, right? The amount by which the next step increases, it's fixed. Is it not? So we have a pattern over here. It's a sequence, and this sequence is called as correct. So this sequence is your, the sequence is an AP, right? So how do you add this up? Well, just add the bar. Take each of these bars, stack on one another, and we can add them. Basically the idea of summation. But in time, we'll be able to see that, or if you are keen about how do we simplify this, we'll be able to derive a formula. So in this program, the final answer is seen over here, 185. If I stack all of them, you can see that it's 185. Okay, so this is 175. If I zoom in over here, so this is 185. But how did I get that? Well, let me go to this line of code. So sum of the sequence, it's over here. And basically this is it, this line. So n by 2 into 2a plus n minus 1 into d. So yes, we are able to derive a formula for this particular scenario, right? With a being 5, that is the first term, d being the common difference, n being the number of terms. So using all of these facts and using a formula, Sn is equal to n by 2 into 2a plus n minus 1 into d. So using this particular formula, we are able to find the sum of all of these 10 terms. So here the underlying principle is pattern. Okay, so in both of this, we are adding things up. Here it's a pure multiplication. Here the underlying principle is pattern. That is the concept of AP. Okay, so I need to change this because I promised I'll use the shortcut. So underlying principle over here is the concept of AP. So to conclude, we can tell that if we have to find the sum of numbers following a particular pattern, we can use a formula to find the sum, right? If there is any sequence, it can be just plain single set of numbers, or we are adding up things which are following a particular pattern. In this case, it's AP. There are many patterns. We'll be able to find the sum using a formula. We can derive a single expression which can give us the final answer, right? So that's what we have to observe. Okay, next task, to find the area under the graph. So what we are seeing is a linear graph. So this is 1 and this is 21. Okay, I think it's 21. Yeah, it's 21, correct. So this is 21. So starting from 1, it's going to 21. I want you guys to find the area within this space. This space. Okay, yeah. How can we do this? Well, we can break up this structure into two parts, one being a rectangle and another a triangle. So this is your rectangle and that's your triangle. So the area of these structures are nothing but correct combination of two figures, or we can go with area of the trapezium and all of that, but point is we can find it in so many different ways, is it not? I'm able to find this. So underlying principle over here is I am able to divide it into parts. What a number of parts that we can divide, that can vary. Then calculate each area and finally add them up. This is the underlying principle, correct? Now this was the first case, now the second case. Now it is non-linear. This was clear-cut linear. We could divide into triangles and rectangles and all of that, but this is non-linear. We have studied this when we were kids. How do you do such a graph? How do you find the area over here? So this too has the following structure, starting off from 1 and this is 100. So how do you add this? Okay, let me help you guys with this. So one of the methods that you would have studied is the following. So what can we do? Yes, we start drawing grids or rectangles, right? Then find the area of each of this rectangle and then add them up. Is it not? So this is going to give a very poor approximate answer. How can I improve this answer? How can I get a better answer for this? What is the funda? Yes, we have to reduce the width of the rectangle. For example, I can make it 0.5. There the unit was one unit. The width was 1 unit. Here the unit width length is 0.5. Okay, now this looks better. Of course, there are a lot of spaces that we are missing. Even a better approximation is even further if I divide this. So things are getting better and better. As and when I decrease the width, what is happening? Yes. Further, I can do this actually. Let me divide this further by 2. So you can see that we are getting better and better answer. So let me do (0.01). Right? So you can see, are you able to see that? I don't know if your resolution is good enough. So I'm able to see a bunch of lines. So we have a lot better answer than what we had at the start. So you can see there are gaps, is it not? This is clear. So yes, we are able to find the area of the structure by doing what? Yes, the underlying principle over here is dividing area using set of rectangles. Okay, then calculate each of them. And finally, we add them up. Right, this is the process. Agree? Okay, we're almost there. We're almost there. So now, mathematically, this idea looks like how? Well, so we can write area under the graph as one is we're going to make use of the formula area of rectangle. I don't have, okay, let me write it here itself. So you're using area of rectangle, which is length into or width into height. That would suit this better. Right now, we have area under the graph to be equal to. So in case the width is 1 unit, right? So let me go back to that. Now, in this case, the width is 1 unit. So let me zoom in for clarity. So the width is 1 unit, right? And the height depends on the function. This particular function is f of x is equal to x square. But anyways, we don't need that. So let me write it in this way. Width is 1 unit. This is the first rectangle. And the height I can obtain by f of 0. Right? Because this height is confined by f of 0. Whatever this point is, in this case it's 1 actually. So this would be, height would be 1. Next rectangle would be again 1 because the width is 1. And the height depends on what is f of 1. So this is 1. This is f of 1. Right? So this can keep happening. So this will keep happening till the last one. And the last one is okay. So last one height is, if you can go up, I can go up, of course. So this is till 9. Okay, 10th is not included, till 9. So 1 into f of 9. You guys agree? So can I write this as sum of I 0 to 9. So we have 1 into f of I. Can I write it in this manner? Agree? So this is a sum of this particular width, this particular height, varying from 0 to 9. Agree? When I decrease the width, what will happen? The area under the graph will be equal to summation of, now what will happen? So this, whatever was there, if I reduce the width by half, 0.5, how many rectangles will be there? If you count it, so each of this block has 4 of it. So 1, 2, 3, 4, 5, 20 of them. Each block has 4, there are 5 such blocks, so there will be 20 of it. So basically from 0 to 19. Agree? Not 20, 19. Same as this funda. But here the width is 0.5 and the height is f of I into 0.5. Okay, so every half a unit, if you can, which I will zoom in. So every half unit, so we can see that we are taking the height. And that's why I have to multiply with 0.5. What if I divide this to 0.25. This you guys can graphically do it. I'm going to write the answer over here. So there will be how many units, how many blocks? 40. So 0 to 39, 0.25 into f of I into 0.25. Okay, so what is the best possible scenario? When can we get the best possible, closest possible answer to this? Should I increase the width or decrease the width? Yes, I should decrease the width. So in mathematically, the least possible width is what? How do we represent mathematically the least possible width? Yes, limits. Okay, so limit n tending to infinity. This number, right, instead of 39, 40 or 60 and all of that, if it tends from, so in this case it should be 0, my bad. Okay, whatever the limit is. So the starting to the last one. So if I move from 0 to n minus 1 or whatever the number may be, and this n tends to infinity, as many small rectangles as possible. So this is known as infinitesimally small width. So the last case is when the width of the rectangle is infinitesimally small. This is possible if we have n moving towards infinity. So very large number of rectangles. Agree? And the width will be infinitesimally small. So I'm not going to write that word. It's over here. And n is your, this entire thing is your sum of all rectangles. And this is nothing but your height. Height can be anything. So it's dependent on the function. Okay guys, right? That's what we saw. So this idea is nothing but your integration. That's it. So integration is a special case of addition. It's an advanced form of addition. That's all. Instead of adding discrete numbers, we are adding up an infinite number of infinitesimally small pieces. Okay, yes. Infinitesimally small matlab very small. Like whatever smallest unit you can think of, smaller than that. How infinity is a very large number, infinitesimally small means it is that small to a point wherein you can't even measure that. Okay, so this is the funda. So to conclude, let me start off with whatever we did in the first slide. We wanted to add certain numbers. This was a straightforward pattern, so we could use multiplication. Next, underlying principle was an arithmetic progression. So this is basically underlying principle over here is pattern recognition, right? Here too is another form of addition. So in this case we are able to add by dividing the structure into smaller pieces. The same funda is over here. So underlying principle was this. Here the underlying principle was to divide it into smaller rectangles. Okay, this is what you have studied in your, I don't know, 6th or 5th grade, right? So mathematically we can do so with the help of the idea of summation, and summation of different widths we saw. So smaller the better is what we can conclude. To conclude, smaller the better. So this is your underlying principle, to be honest. Smaller in case of rectangle area or width. So when we tell smaller, it has to do with width of the rectangle. Smaller the better. This is the underlying principle. So finally, we have a representation for the smallest width possible, that is limit n tends to infinity. All in all, this will represent that delta x has to be, the width has to be very small. And that is nothing but your integration. Okay, so official definition and everything, I'll show it in the next video. For now, I would like you guys to copy this. Yeah, copy everything. Maybe not this graph. Okay, so not this. That's left to you guys, but not required.